This project is a form of automated code verification. It uses a tool called SemGrep to detect either the absence of good coding practices or the presence of bad ones. SemGrep itself uses rules to detect these. Due to time constraints, this project focuses on only 2 bad coding practices. The first of which is no argument validation, which simply means that the type of an argument is not checked before it is used. And the second is incorrect authorization, where authorization is performed in an unsafe manner. This project is intended for use on a developer's local machine, allowing quick and immediate feedback, as well as in a repository, which can run more comprehensive tests. The ideal workflow for this can be seen at the bottom. Bad coding practices can lead to security vulnerabilities within a system, and as such, many practices are put in place to try and prevent them. One of the most commonly used practices is manual pair code review. This involves the developer checking another developer's code to ensure that it is safe and secure. As one might imagine, this involves the developer stepping away from their own work and doing non-productive work. This project aims to automate the whole code review process, ensuring that every developer is able to focus on their work and does not need to go through unnecessary non-productive work. As well as this, detecting bad coding practices will improve the overall security of the system. Results for this project were gathered by using publicly available repositories. 9 publicly available repositories were used to create the rules, while 4 were used to run them. As you can see, the project performed extremely well when detecting occurrences of no argument validation. However, had a significant accuracy drop when detecting incorrect authorization. Poor accuracy in detecting incorrect authorization is likely due to the different ways that the same function can be written. As the rules rely on code being previously seen, encountering code that has not been seen yet may result in the bad practice not being detected. A generalized rule set is difficult to create due to the massive amount of variations in code that can be seen. As such, this project is more suited to a sort of safe and tight-knit environment where code can be expected in one particular way and coding practices can be enforced. For the demo, we'll first start with the practice of incorrect authorization and then move on to no argument validation. So this right here is the rule for incorrect authorization. This simply matches this specific code snippet against the code in the file that you're trying to find the bad practice in. So this simply finds any function that contains this particular bad practice, that is an if statement with an immediate throw of an error followed by a function. The code that we're going to test it against, this is actually a real life code snippet. So this snippet of code was taken from one of the repositories I used for testing this project. So this first bit here is the bad practice, while the second snippet of code here is what I have personally done to fix the bad practice in the code, and this should, not be found as it's no longer a bad practice, it's a good practice. So we'll go ahead and run this rule. As you can see here, it found one occurrence of a bad practice. This bit of code right here corresponds to the bad practice seen before, whereas the second bit of good practice isn't actually found at all. Then we'll go ahead to the no validation. This is actually the opposite of the first rule. Instead of finding the occurrence of the bad practice, it checks for the absence of the good practice. So what this is doing is it's finding any function with an argument, and then it's checking that that function does not contain a check statement before the argument is used. So once again, we're going to use some real world code snippets. So this first bit of code is actually another one taken from the test repositories I used. Well, once again, the second one is what I've done to change this bad practice into a good practice. So we'll go ahead and run this rule set against the code. And once again, there's only one rule violation, with this corresponding to the first bit of code, which is the bad practice. The second good practice isn't found at all, so this shows that these rules can distinguish between bad and good practices.